So in this section, we are going to learn about stack. What is stack? It was a concept about last in first out, or sometimes we call it LIFO. We are going to learn what is the abstract data type for stack, and then example of stack, and how stack can be used to optimize the complexities. Stack. What is stack? At the first time, I would like to explain about the abstract data types. When you learn about the object-oriented programming, you learn about class. Okay. So in the class, we also learn about inheritance. We learn about the modularity. We learn about the encapsulation. So those kind of things are the basic concept of the object-oriented. And whenever we want to apply some kind of data structure, we usually use this abstract data type or some abstraction. So ADT or abstract data type is an abstraction of data structure. So like what you already did on the assignment, okay, you have the vehicle. Okay. When you have the vehicle, it means we have all the properties of vehicles. And we can have subclass, like we have bus, we have sedan, okay. The same with this data structure, we can build an abstraction. So we can just make all the same properties and you can use the methods to different kind of problems. Because this is the ADT. So the ADT specifies what is the data stored, what are the operations on the data, and what are the error conditions associated with operation. For example, I want to make an ADT to model a simple stock trade. Stock. So yeah, like tuja, investment. So if we want to buy stock or we want to sell stock, then there will be operation. For example, I want to buy a stock. So I want to buy the stock, and how much do I want to buy, and then in what price I buy the stock. So I have three parameters. If I want to sell the stock, so I also can have three kind of parameters: stock, share, and price. Or let's say I already buy or I already sell, but I want to cancel. Then I want to cancel the order. The order is an object from this one. So if you already know how to create this object or the data or the method, then yeah, you can have the abstract data type. And then we can specify what would be the error. So let's say if I want to buy or sell, but the stock is not exist, then yeah, we can have some error message. If I cancel, so if the order is not exist, then we also can give the error message. So the ADT usually we have those things. Now in the stack, we can create a stack ADT, or stack abstract data type. The stack ADT stores arbitrary objects, so it can be any object. And for every ADT, there will be insertion and deletion. So in the array, we also learn about insertion, which is using the add operation, and we also learn about removal. Okay, We use del to remove an element in the array. In every data structure, you will have these two, insertion and so the insertion and deletion follow the last in first out scheme, or we usually call as LIFO. Last in first out. So we can think about like spring-loaded plate dispenser. For example, yeah, I have two operations, push and pop. In the first operation, I would like to make a new element, which is 1. And then I'm going to push a new element, which is 2. So I also have a new operation. In the second operation, I want to put the element 3. In the third operation, I want to put the element 4. I want to put the element 5. I want to put the element 6. So we call push as the insert an element. So we are going to push an object. If we are going to remove it, we use pop. Pop means we are going to remove, and the removal returns the last inserted element. So if we have 1 and then 2 and then 3 and then 4 and then 5 and then 6, so the last element will be 6. So 6 will be removed first, and then 5 and then 4 and then 3 and then 2. So the main stack operation is push and pop. But there might be some other operations. For example, top. We have object top. It means I want to know the last inserted element without removing. So I want to know what is the current last element. Okay, if it is in this operation, then the last element is 6. If we are still in this operation, the last element is 5. Length. So we are having an integer. It means that it will return the number of elements stored. If I have 6 elements, then this integer will give you 6. If you have 4 elements, then it will return 4. Boolean is empty. It means whether no elements are stored. So if the stack is empty, then it returns true. If the stack is not empty, it returns false. Now let's see. We have a stack, and let the S is a stack, and it starts with empty list. Okay. We have S dot push 5. So the return value, there will be no return value. Now the stack content will be 5. Okay. And then I'm going to push 3. So if I push, it means I'm inserting an element at the end of the loop. So now the content is 5, 2. So this operation is a sequence. Okay. So this is a sequence. Now you have 2 elements. If I want to check length S, then it returns 2 because I have 2 elements. What about if I pop? What is pop? Pop is to remove the last element. Then I will remove the last element 3. Now the stack content will be only 5. If I'm going to check whether S is empty or not, it return false because the stack still have one element. I pop again. So as the pop, then it returns 5. It is the last element in the stack. Then now the stack become empty. I'm going to check whether it is empty. Yes, it is true because no element in the stack. If I do pop, what happens? That's why it will be empty. So we need to do something. If you want to handle this error, yeah, we can use like raise, try catch. So the program will give the error message without stopping the program. Now I'm going to have a new element, push set. So we have set. I'm going to push 9. So 9 will be added at the last index. I have top. Top. What is top? I want to check the element at the last index, or I want to check the element at the top. So the element at the top is 9, or the element at the last index is 9. Then we will return 9. I'm going to push 4, so I insert 4. Then now we have 7, 9, and 4. Length. Length, we know that there are 3 elements, so it will return 3. As the top, so I'm going to remove one data. The removal will be taken from the last index. So the last index is 4. So 4 will be removed, and the remaining stack is 7 and 9. Push 6. So I'm going to put a new element 6. Push 8. So I'm going to put a new element 8. And then let's say pop. So I'm going to remove the last element. And so on. Okay. So this is how the stack goes. So the direct application, yeah, we can use it as the page visited history in the web browser. Okay, so in the web browser, let's say now I go to Google, and then after I search something, I go to the website 1, and then I go to website 2. So we can make this as a step. The first data is this website, and the second is this website. The third is this website. So if I want to return back, yeah, I can go to the previous data. Or undo sequence in the text editor. So if you do with the Word, or if you use Hangul, okay, if you do something and then you want to undo, so the application also use that. Chain of method calls in a language that support recursion. So if you use some kind of NLP, like the natural language processing, we can also use stack. Stack can be applied to any other data structure. So it is an auxiliary data structure for algorithms. Let's say if you use, maybe you want to analyze the genetic algorithm. So in the genetic algorithm, when you analyze one seed, then you can apply that. And this is also a component of other data structures. Usually the stack can be implemented using array. What is array? We learned already from the previous section. Array is just a sequence. So a simple way of implementing stack ADT is using an array. So we can add the elements from the left to right. So whenever we have a new element, we add from the index 0, index 1, index 2, and so on. And there might be a variable to keep track the index of the top element. So the index of the top element means, for example, P. And then when we use array, it is obvious that the array storing the stack elements may become full. So we learned from the previous section, there are two strategies, incremental strategies and doubling strategies. So we can make the array as a growable array. So a push operation will then need to grow the array and copy all the elements over. Stack is a data structure, and we need n space. Because if the number of elements 6, then we need 6 space. So the space used is O(n). And then each operation runs in O1. It is the amortized in the case of a push. So people use stack because it is very efficient. When you push, you just need one operation. When you push, you need only one operation. And when you pop or remove, it also needs only one operation. This is an example of the array stack. Because this is the abstract data type with the array. We have the class array stack, and then we do the construction. So we construct the data. So this is the data with empty list. And then I want to know the length. So I want to know how many data that we have is empty. So if the length of the data is 0, then we will return the value, which is 2. If it is not 0, then we will get the value false. Push. So when we push, it means we are going to append the element E into the top. It means I'm going to check whether the top is available or not. So I'm going to check if the data is empty or not. If it is not empty, then return the data at index -1. What is -1? Index -1 is the last index. Okay, so that's why we call it as the top. And then we do pop. Pop means we are going to remove. First, we need to check whether the data is empty or not. If the data is empty, then we can make the error message stack is empty. If not, then we can just do the pop. Do you know pop? So in Python, there's a function pop. So for example, A is 1, 2, 3, 4, 5. Okay. And then I will know that A is an array or is a list. And then I can do pop. So when I do the pop, then I remove the last element, which is 5. So you will get A is becoming an array with 1, 2, 3, and 4. The last element has been removed. Okay. So using this pop, we can create a method pop. So before we do the pop, we want to check whether the stack is empty. So there are some example of that. Parenthesis matching. So whenever you have a kind of mathematical notation or maybe some words, I want to make the pair. Pair means if I have the opening parenthesis, then there should be a closing parenthesis. So the parenthesis can be the common parenthesis, or we call this is curly parenthesis. We need to have the closing curly parenthesis, and we can have also the square parenthesis. The square parenthesis and closing. So we need to check if we have this one, whether it is correct or not. So we can use that. You can check this one, whether it is correct or not. This is incorrect because it starts with closing parenthesis. This one is incorrect because the sequence is not in the order. This one is incorrect because we have only opening. Okay. So we can use the stack. This is the algorithm. We have X. We call X it is a token. It is an array. And then I'm going to have N. N is the number or the length of the element of the array. And the output will be true if and only if all the grouping symbol in X match. If not matched, then it is false. So we can have the loop. Okay. So S that be the empty stack, and then we will do the loop from 0 until n-1. If xi is an opening grouping symbol, then push into the stack. After we push, okay, we will check again. If X is closing group symbol, so there will be some condition. If it is empty, then return false. If we want to remove it, and if the removal did not match with the component in the stack, return false. And the last one, we want to check whether it is empty. If it is already empty, then it return true. So you can see the operation is here, push, and the operation is here, pop. This is the code. This is an algorithm to find the parenthesis matching. The lefty means the opening parenthesis. the right T means the closing parameter. So let's make an array stack as an empty S, and then I would like to check if C is in the expression. So the expression is the data that we want to check. And then I want to check if C is lefty. So if C includes in the opening element. If yes, then let's push. And then we will check if if C in the right T. Right T means the closing parameter. So if it is empty, just return false. If the right T index C not equal to the left T index S pop. So if I know that I have an opening of parenthesis, but the index is not same with this one. What is the index? This is the index. Index 0 and index 0. This is index 1 and this is index 1. This is index 2 and this is index 2. So every index should match between the left T and the right T. So the right T index should be the same with the left T index when we pop the data. So if it does not match, then return false. If it matches, then keep continue until this thing. So we will return until S is empty. I think I give you the code. I give you the IPYNB. Okay, I have the stack. So this is the array stack that we learned previously. So it is a LIFO or last in first out, and we have all the methods. So this is the example given by the authors based on the PowerPoint. Okay, and yeah, this is the matching algorithm. So we have left T and right T. So we want to check whether this parenthesis already matched or not. So if I run this, now I have a problem. This matches. I have 3 opening parentheses and I have 3 closing parentheses. So the result is true. So let's say this one. I have opening, 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 and then the closing is only 2. So it is 4. So we can just use stack for this one. We push and we pop. If S is empty, then it means it is matched. So there's also another thing we can use stack with the matching. We call it this HTML tag matching. In the HTML tag, yeah, if you learn the web programming, whenever we have an opening tag, let's say this is name, and this name will start with the triangle bracket. For fully correct HTML, each of these tags should have a pair with the closing. So the closing is using the triangle bracket with slash. So for example, yeah, this one is body, and I should have body at the bottom. I have center, then I should have a closing center. If I have h1, I should have h1 as the closing. If I have p like this one, then I should have slash p as the closing, and so on. So we need to make an algorithm to find this tag mentioned. So this is the algorithm. I think I give this code. Okay. So the code, maybe I will just explain briefly. So it is to check whether the HTML is matched or not. So first we will make the array stack, and then from the row or from the data, we need to find the opening bracket. After we have this opening bracket, so while j not equal -1, so -1 means when we do the searching, yeah, we still find something. So if it is already -1, then it means finished. So if j is not -1, so it means we will still have the true. So we will check k raw, find the closing, and make that one as the j+1. After we have, if we cannot find it, then it is -1, then return false. So we want to get what is the tag. So the tag will be the j+1 until k. Do you know what does it mean? So if we have body, it means we are going to find the element. It is a string. Okay? It is a string. So this is a string and index 0. B is index 1, index 2, index 3, index 4, and this one is index 5. So that's why we put a number in this one. So after we find it, we want to know the tag. So the tag will be from the j+1 until k, until the last one. So if tag is not starting with slash, so we know the last should be started with slash. If not start with slash, then push the tag. And then we will check whether it is empty or not. If it is not empty, then return false. So we will do again checking the tag from the index 1 until the last index. So if the tag 1 until the last index does not equal to the pop, it's also false. So J is the index for the opening triangle bracket. So if you run this, So I have the HTML. Okay, this is the HTML. And then it will be ended with HTML. So in this case, okay, it is true. We have HTML, but ended with body. So it is false. But for example, I have HTML, body, HTML. And then it starts with the slash. So it returns true. So there are so many applications. Now we can also use the stack for this kind of arithmetic expression. So in the Python, you know that there are some operator precedence. Operator precedence means if we have multiplication and division, it is more priority than plus and minus. And associativity, it means if you put bracket, then it will be more priority than without bracket. So the idea is push each of the operator on the stack, but first pop and perform higher and equal precedence operation. Okay, I will explain this one on Monday. Okay. So I will stop here because of the time. Let's